Wind power has been used since about 1 AD, but not for energy. Ancient civilizations harnessed the power of wind for drawing water from the ground from wind pumps, as well as grinding grain in a windmill. But by 1887, wind was harnessed for electricity, about 130 years after Benjamin Franklin discovered electricity. There are three factors that contribute to the amount of energy produced.
Oh, it's still going.
The orientation and size of the blades, the aerodynamic design of the blades, and the amount of wind turning the rotor. The orientation of the blades can be vertical or horizontal. A vertical blade can receive airflow from any direction, but has a low efficiency, while a horizontal blade can only receive airflow from one direction. It has a high efficiency. The aerodynamic design of the blade maximizes the rotation of the rotor, creating a high pressure and a low pressure pocket to cause the blade to rotate more, producing more electricity. The modern wind turbine uses a common simple machine, the gear and axle, to maximize the electricity output of the rotor. The low-speed shaft turns an axle with a large gear, in a gearbox, to increase the gear ratio. This powers a generator which leads into a high-speed shaft. The electricity produced goes down the tower and moves toward a power grid for storage. The yaw gear system allows the horizontal wind turbine to turn, or yaw, to the face of the direction of the airflow.
The wind turbine is made out of mostly steel. It is also made out of fiberglass, resin or plastic, iron, and other metals. It can operate in most environments that are windy. Wind turbines are most efficient in flat, open areas. Wind activity is usually more intense in higher altitudes. Most modern turbines are over 100 meters tall, the largest having a rotor diameter of 220 meters. This wind turbine powers 16,000 European homes to this day. On average, a single wind turbine can power 750 American homes or 1,500 European homes. A German physicist by the name of Albert Betz calculated that a wind turbine can only ever capture 59.3% of the wind's energy. However, wind energy is still the most efficient energy source compared to all other energy sources. It is also the second most inexpensive energy source behind solar energy. The average cost of a single wind turbine can be from about $2 to $4 million, with a maintenance cost of about $45,000 per year. The cons of wind energy are that it can disrupt natural scenery. The airflow can also be unpredictable on a day-to-day basis. There can be wind on one day, but not the next.
Humans have been developing the most efficient way of harnessing the wind's energy for many years now, so the room for improvement of wind turbines is not very expansive. David Yanez, however, was able to create a bladeless wind turbine in hopes of creating a more efficient design.